Carl Zakarian here with NetFocus Technologies. In this video, I'll demonstrate and compare the cable testing capabilities of the Ethernet switch against a handheld NetLi LinkRunner AT4000 network tester. I will perform a series of tests ranging from a simple pass-fail check and a detailed wire view pin test to an in-depth power over Ethernet cable test. When we look at an Ethernet network cable, from our view, it may look simple, but their internal structure is crucial. More importantly is the diagnostics tools we use and how we perform a network cable test. By performing these tests, you will see how each cable test impacts your network speed and reliability. Most managed switches feature a cable test option that reports the cable status as normal or open by checking the integrity of the pin termination at both ends of the cable. In scenario 1, I currently have an Ethernet cable connecting port 5 on the gigabit switch to a PC. Logging into the web management of the switch, I will perform a cable test by navigating to the Monitoring tab and selecting Cable Test option. I will select port 5 and click Apply. Running this test indicates the cable is normal with no faults. However, a close inspection of the results doesn't explain why the cable status is normal. For example, is this cable truly normal, or does it have an undetected fault that the switch test missed? Well, let's find out. I will now connect the far end of the cable to the LinkRunner AT4000 to perform a series of tests. We will begin by performing an auto test. To do this, I will tap on the auto test icon. On the next screen, I will tap on Start. The auto test will automatically validate the connected port by checking multiple aspects, including switch port speed, duplex settings, power over Ethernet capability, network connectivity, and latency measurements for the connection. As you can see, we are connected to port 5. Although the switch indicates the port is 1 gigabit capable, however, it can only do 100 megabits per second, full duplex, as indicated in bold. As we noted earlier, port 5 is a gigabit port, and the switch's earlier cable tests reported everything as normal. Clearly, there's an issue. So why is the network connection not achieving a 1 gigabit link speed? To find the cause, I will connect a wire view mapper to the far end of the cable. The wire view mapper will terminate the Ethernet cable and test the connection integrity of each pin. We tap on the cable test icon and tap Start to begin the test. You can see here that pin number 8 is cut at 3 feet. This is the reason why we're connecting at 100 megabits per second and not 1 gigabit. 1 gigabit per second Ethernet requires all 4 pair wires to be intact and terminated. The LinkRunner AT4000 shows us the fault and clarity, which clearly displays the type of fault and its distance to fault. In scenario 2, we have a network cable with intermittent connectivity issues. Logging into the web management of the switch, I will perform a cable test by navigating to the Monitoring tab and selecting Cable Test option. I will select port number 5 and click Apply. When we perform the switch's cable test initially, it reports normal. However, a second test immediately reports crosstalk. This raises a critical question. Why are the switch's results inconsistent? Is the cable normal or faulty due to crosstalk? As demonstrated, cable tests performed directly from the switch often produces unpredictable and unreliable results, making diagnosis of intermittent issues like this extremely difficult. To diagnose this issue, we will again use the LinkRunner AT4000. I will connect a wire view mapper to the far end of the Ethernet cable. After selecting the cable test icon and start the diagnostics, the results immediately show the fault. Here you could see that pin 1 is incorrectly terminated to pin 3, and pin 4 is terminated to pin 1 on the far end. This poor termination at the connector is the root cause, creating multiple wire pair faults across the cable. Let's now examine scenario number 3 involving an access point and a power over Ethernet switch. The access point is connected to a Power over Ethernet gigabit switch. The PoE switch can successfully power on the access point. However, the access point fails to establish a network connection. When we run the switch's built-in cable test, it inaccurately reports a normal status for the connection. To diagnose this issue, I will use the LinkRunner AT4000 to test the cable and validate the network connection. Tapping on the auto test icon immediately provides the following results. Here we can see that we are establishing an intermittent connection and we are receiving 13 watts of power over Ethernet. However, upon further diagnostics, we are unable to obtain an IP address from our DHCP server. The DHCP server is fully functional with an adequate pool of dynamic addresses. We will now dig into the cable side of things and see why we are getting power only and no network connectivity. I will start by connecting a wire view mapper to the far end of the cable. We then navigate to the cable test function and run the diagnostics. From this screen, you can clearly see the white-orange wire on pin 1 is completely severed. The result is the access point receives power and boots up by using wires 4, 5, 7, and 8, but the Ethernet link cannot be fully established to send or receive network data traffic. You can easily go from perfect speeds to total cable failures. The LinkRunner AT4000 can validate the condition of your network cable. Don't assume a connection is fast just because it links up. Always verify your speed and check for errors if you suspect a problem. Alright, I want to thank you for watching this video. Take care, see you on the next one.